Fantastic. Hello there, Master Hellish here, and welcome back to my coding game Let's Play. Before we crack on, I've had a couple of questions when starting out this series. I asked for a lot of feedback and you guys gave it. Thank you very much for that. But I've also been asked, and people have said, oh, I wish I could get into coding, or I wish I knew how to do it, or where do I start if I want to do it? Well, I'm just going to show you how quick and sillily easily you can do this. On any Windows PC, you can just create a new text file, right, like this. You can call it whatever you like, and then make sure that the extension is VBS, that's Visual Basic Script, okay? So you can then edit this script in Notepad, and you can use a function, just one function, one line of code, MSG BOX, and of course the brackets because it's a function. And what we can do is we can pass that function a string, so we put it inside some speech marks, and we go hi viewers. There we are. Save that text file and close it, and all you got to do is double click to run it, and we get a message box, hi viewers. That's it. I just wrote a program and executed it in seconds, and that is how easy programming can be. So don't be scared of it. It is something that you can build on and work on and do. Now, if you want to start out, I have something that you can look at. Scratch is an amazing application, lovely little program that you can use to make basic things. So you can make little animations, or you can make little games using Scratch. And what it does, it allows you to put together routines, like things like these you can see up here in the corner. When clicked, repeat, move, change colour, and then you select the colour, play drum for so many beats, things like that, and you put all these things together and you can make quite complex things with it, but it helps you get the idea of loops, procedures, variables. It gets those sort of concepts in your mind before you can go out and start coding. If you want to check that out more, the link to that is in the description. So that's the first place I would suggest you go. Once you've got some of those sort of basics, start playing around maybe with some VBS scripts and just do lots of Googling to figure out what different things you can do with it. There's loads of awesome stuff. As long as you've got a Windows PC, you can do VB scripts. Then things like CodinGame come in lovely. And this is where you can harness those basic skills that you've learnt, practice them and learn more, figure it out. Because even if you don't know the programming language, you can just Google the little bits or get hints and tips from the rest of the site. So, welcome to Power of Thor. This is my third episode in the Coding Game Let's Play, and let's crack on. So our goal says your program must allow Thor to reach the light of power. Okay, fair enough, I'm with that. Thor moves on the map, which is a 40 wide by 18 high. Okay, so we've got a kind of fictitious grid. Note that the coordinates x and y start in the top left. Okay, so we've got x and y up here in the top left. In fact, it's labelled for us, lovely. And top left, and the cell has a coordinates 0, 0. So again, we're counting from 0 as we do in computing. And the most bottom right corner is the coordinates 39, 17. So one shorter than you would expect because we're starting from 0. Once your program starts, you are given the variable x, the position of the light power that Thor must reach, y, the position of the light power that Thor must reach, and the variable of the starting position of Thor. Okay, so I'm guessing we're given where he is, we're given where our objective is, and we've got to get him there. So we'll have a look at more in a second. At the end of the game turn, you must output the direction in which you want Thor to go along. Oh, right. So we don't have to tell him how far to move. At the end of each turn, after the end of each cycle, we have to tell him which way to face. Now, we can do it simply with just northeast, southwest, but we can probably do some more complicated things and move diagonally with northeast and so forth. Each movement makes Thor move by one cell, so we do a movement every turn. Victory conditions, Thor reaches the light of power. Fantastic. Lose conditions, Thor moves outside the map. Interesting. So we've got an initial phase, and then we've got some extra things to figure out. There's some hints and some initialization inputs and some constraints. So let's see, what outputs is it expecting? North, east, right, okay. So let's have a look at what code we have so far. We've got our main code here where we're going to get, we've got an inputs as a string. So it reads the input as a string. And then it looks like, oh, right, okay. So what happens is this console read line reads in the information given to it, the variable x, y, then the tx and the ty, so Thor's position and the light's position. And then what they're using this split command, because each of those items have a space between them. And this split command splits the string up into different parts. So if we had a sentence, the cat jumped over the mat, when we use this split command, it creates what we call an array. And this is a special variable where something is stored in a number of different segments. Think of an array like a set of pigeonholes. So in the first pigeonhole you can put a variable, in the second pigeonhole you can put a variable, and that's what we're doing. We're getting this big string and we're splitting it up by the space, and the split command can be used to split things up with different things. You can use commas and stuff. So what we're doing is, in my example, in the first pigeonhole of this a variable input, we've got the. In the second pigeonhole it'll be cat, and then so on and so forth. And what we're doing, the program here is using this split command to put this array inputs into the program, and then it's saying inputs 0, because again we start from 0. So in the 0th pigeonhole we have light x, in the 1th pigeonhole we have light y, in the 2th pigeonhole we have initial tx, so initial Thor position x, and input in the input pigeonhole, the third, well, it's the 4th one, but it's actually counted as 3, is the y position. So we've got the x, y, and the tx and the ty. So we have to figure out what direction things are, and then output a direction back. Now you can see here that the console is automatically putting out southeast as an example, and we've got some bits of information here that we don't have to worry about. So let's play this test case and see if we can do it nice and easy with just saying go southeast all the time. Let's see what happens. So there's Thor. He's heading southeast, and apparently he headed out of the gameplay area. Thor wandered off the path and died. Well, that's a bit harsh. Dying just because you wandered off the path. Now, there's two ways we could go about this. Well, there's actually lots of ways, but there's two main ways we could look at it. We could try and do a complex way, find out the exact direction we need to travel towards the light, and then head in that exact direction. But there's a slightly more simple way, and we'll start with that, and that's we can go work out how many difference we are in the x direction or the y direction, and choose to go north or south for a bit, and then work out how different we are in the y direction, and choose to go east or west for a bit. So let's do that. Right, so the first thing we're going to do is we're going to get rid... I've got remaining turns equals constant. The remaining amount of turns Thor can move. Okay, let's get rid of that. So we're going to put our code here to work it out in this game loop. What we're going to do? What are we going to do? Well, we're going to get these inputs, and we need to figure out which way to go and how long for. Let's start with a little bit of basic stuff. We'll use an if condition. If we'll say the light x is greater than than Thor's position, then we need to head. If the light is greater than Thor's position, we need to head east. Because look at this, we've got our legend in the top right of this image, and now x goes off to the right. So if the light position is further off to the right than Thor, then Thor needs to go to the right, which is east. So then we're going to say we're going to create a variable, and our variable we'll create it up here where all the other variables are created. So we'll go dim direction. Let's call it direction. And it is a string. As string. Okay. So we're going to go, if it is, we're going to go direction equals, and then we're going to put east. And we're just going to do that to begin with as a tester. So let's, and then we'll, should we put else? Else. So if light x isn't greater than tx, then we need to go the other way. So direction will equal west. There we go. And then we need to end the if. So now we're going to put this direction as our output down here in this console write line. And let's see what happens. So let's try again with this new code. And we'll see what happens. Now Thor is actually going in the correct direction this time. He's heading off towards that. And is he going to get it? Or Thor might actually reach the light? Yeah? Hey! All we did was tell it to go east or west, and Thor actually went the right direction. Well, that was easy. Fair enough. Let's move on to the next test case and see what happens. Our code's going to have to become more advanced to cope with all the different scenarios here. So now we've got a problem where Thor needs to decide if he needs to go up or down. And he went out of the area again. Right, so here, what we need to do is we have to have another condition. We have to find out if the two conditions are the same. If they're the same, we don't want to go up or down. Sorry, left or right, east or west. We want to go up or down. Now, we could do what I'm about to do with a case statement, but I'm going to keep it moderately simple, and we're going to do what we call a nested if. So we're going to say if light x is equal to Thor's x position, then we don't want to go east or west. What do we want to do? Nothing. So what we're going to say, instead of equal, we're going to say not equal. I think in VB it's like that, where you get an arrow in both directions. So if if the light's position is not equal to Thor's position, then Thor will decide whether to go east or west. Else, he won't. No else condition, just end if. Okay, there we go, that's it. Job's a good one. So what we're going to do now is we're going to kind of copy this, and we're going to kind of replicate it out. There we are, we've got the same thing again. But instead of x, we're going to do y. Okay, so we're going to check for going up and down. Now we may have to really rewrite this code later on in terms of being able to get directions and go the right way and so forth. But let's do this. So if the y direction, if the light source is greater than Thor's position, he needs to head south. So we're going to put it here. S for south. And if we got the opposite situation, if the light source is less than Thor, he needs to go north. So there we are. So now Thor can decide whether he needs to go north, south, east or west to get to the light source. However, we haven't considered diagonals, and we haven't considered turning corners yet. So let's just, well, I automatically press Control S, because whenever you do coding in Notepad and stuff, that's what you do. You do Control S, you save your stuff. Let's try this scenario again. So in theory now, Thor should be able to work out that he needs to go north, and there he is. He's going north to get the light. Brilliant. Well done, Thor. So now we've got an easy angle scenario. So if we look at this, Thor has to go south to get to the light, but he just keeps going south. That's no good at all. So what are we going to do about that? Well, if we want to, we can cheat a little bit with some overrides. Bearing in mind, you've got to remember that each one of these if statements, when we're setting the direction, if we set that direction again afterwards, we're overriding the previous command, because then the final line that gets written to the console is that direction. So what we could do is we could say if, for some reason, the difference between x and, let's see, the difference. So we go that minus that is equal to the y position. I'm kind of thinking as I'm going here. I hadn't thought this minus that. So, good. Right, okay. What I'm trying to do is work out if there's a possible diagonal. Okay. So we're saying that if, there we go. If the difference in x is the same as the difference in y, then we can go diagonally. Okay, but we have to work out which diagonal we need to go. Wow, this is starting to get complex, isn't it? Especially compared to the stuff we've done previously. There are ways that we can tidy this up. There are ways that we can make it more intelligent, but we'll work on that next time. So what we need to do now is work out which of those directions we need to travel. So we've worked out that there is a diagonal situation going on here. We don't know exactly what the diagonal is yet, but we know there's a diagonal. So now what we're going to do, we're going to do something similar that we did before. We're going to say if light y is, let's do a brand new if. So in this section, if, not fif, not phi, if, let's say if light x is greater than the Thor position x, so if it's over to the right, and light y is greater than than Thor's position y, then he needs to head, it would be southeast, because the x direction goes off to the right, the y direction goes south. So if the light is greater in both positive integers, he needs to go direction southeast. And to make it nice and simple to read, we're going to put just a number of ifs in. Okay. Oh, didn't mean to do that. So we're going to copy this. So we've worked out one direction, work out the other direction, and we'll work out the other direction for the diagonals. There we go. And then it'll be an end if it's a diagonal. Perfect. Okay, so let's just separate that out a little bit so we can see what we're doing. So let's work this out and just change these symbols one by one. So we're going to do all the different combinations. We're going to go, if that one's less than that one, if that one's less than that one, that one's less than that one. So if light x is greater than Thor's position, so it's over on the right hand side, and light y is less than Thor's position, so it's right hand side but up, it's going to be the top, it's going to be northeast. Okay, so northeast. And then if Thor's position is less than if the light position is less than Thor's position, we're going over to the west. And if the light position is greater than Thor's position, we're going down here. So we'll be going to the southwest. There we go. And if finally, we should be able to work out what this one is. If the light x is less than Thor, so it's over to the left, and it is light y is less than Thor, so it's up to the top, top left is northwest. So that one's northwest. So that all works out. Northwest. So now we've got a program that works out if Thor needs to go straight up or down, if Thor needs to go, sorry, that's straight left or right, then if he needs to go straight up or down, and then if he needs to go in a diagonal. And each one is overriding each other. So let's just execute that and see how we go for an easy angle. So hopefully, oh no, look here, it didn't work it out. Something's not quite right. I'm going to have to work on my code. Yeah, this is part of coding, you see. You don't always get everything right the first time, and if you don't get it right the first time, don't be discouraged. Go have a look, work it out, try different things. Let's see what's going on with this code. So let's check our maths. We can see at the beginning of the game state, Thor's position is 31, 4, and the light position is 0, 17. So let's get out our calculator. Here we go, calculator. So we're just going to check this. So it is going to be, let's see here. Well, no, that isn't a diagonal, is it? Or is it? Thor's position is 31, 4, 0, 17. So we're taking away, what we're doing? We're taking away Thor's position from the light. Okay, so let's put the light in as 0. Thor's position is 31, so minus 31 is minus 31. And the other one is, Thor's position is 4, and the light's position is 17. So it's 17 minus 4, which is not going to be equal to each other. 31 is not equal to 13. So our diagonal condition didn't get triggered. Now I thought this was going to be a straight out angle, but looking at these figures, the game isn't giving us a straight out angle. It's not. It's going more of a weird sort of angle. So our code just for going a straight angle isn't going to work in this scenario. It's time now to do something a little bit more complicated and write a better piece of code. This is our main while loop, and in the main while loop we're going to do a few things. First thing we're going to do is we're going to look at the difference between Thor and the light in both dimensions. So if we do xdiff becomes equal to light x minus Thor x, Thor x, there we go. That difference is the space between them. Now it could be positive, it could be negative, depending on whether Thor is left or right of that light. Fair enough. And what we want is Thor to be able to get to the light, and when Thor's at the light, that difference will be 0. Now, we also want a y-diff. Why? Well, we need to track in both directions. So, y-diff, so we'll want a light minus Thor y. Light y minus Thor y. So when both xdiff and ydiff equals 0, Thor will be at the light. We don't need to do anything else. So what we're going to do, we're going to look at the different situations that we can be in, and we're going to try and say, do we need to go straight or do we need to go diagonal? Now the first thing to do is to see if we can just go straight to it. This is similar to what we did before, but we're building it together in a way which means it will work together better. And it means that we'll also change direction during each game loop if necessary. So the first thing we're going to do is we're going to look at if x is 0. So let's say if the diff x is equal to 0, not plus 0, equal to 0. Okay, then we need to do something. What do we need to do? Well, if x is equal to 0 and x is the left and right, we know that all we need to do is move straight up or down, because we don't need to move left and right. The difference is 0. Thor is in the correct x direction. So we need to tell it to go north or south. Now, how are we going to do that? Well, let's see. If the light, let's say, if the light is greater than Thor's position, there we go. Now this is y. We need to be checking y, not x. Because x is 0. We're fine on the x coordinate. We need to check the y. So if the light y is greater than x, that means it's further south. So I guess that means we want him to go south. So we need to set our direction to equal south. There we go. Else we want to go north, because if our light is less than Thor's position, that means that our light is above us on the y-axis. So we need to go north. So else we're going to go direction equals north. And then, of course, we need to end our if. Right. So that is if x is equal to 0. We might go south or we might go north. The thing is, now what we need to do, we need to note the fact that we've moved by a bit. So let's look at that situation. To do this, each time our loop goes through, we need to reduce or increase the amount of our Thor's location. So it's not really initial, it's Thor's, now it's its location. We're not going to bother changing it around into another variable, we're just going to use that again. So if we headed south, our initial x direction doesn't change, it's the y direction we need to change. There we are. So if we headed south, we did y is y plus 1. There we go. If we headed north, then our y direction is going to get smaller because as we go south, further south, remember the legend up here in the top right, as we go north, the y gets smaller. So we need to do y is equal to y minus 1. There we go. And that is it. Our whole deciding if we're going north or south, if our x-coordinate, is all done. But we need an else. What if our x-coordinate isn't 0? Let's figure out what we're going to do then. Well, if our x-coordinate isn't 0, our y-coordinate might be 0. We might be in the right up or down orientation, but need to go left or right. So let's do if our y difference is equal to 0, then we need to do something. Then what are we going to do? Well, it's going to be almost exactly the same. We need to check whether to go left or right, because we're fine on the x, the horizontal axis. We need to decide whether we need to move left or right to that point. So let's do that, and it's going to be exactly the same as what we've just done. It's going to be the same here as this. The only difference is, let's just see if I can get my tabbing correct. There we are. The only difference is that now we're going to be looking at the other direction. So let's just do this, do that. There we go. Neaten it up. And remember our end if. Well, actually, there's going to be an else there. We'll get to the else segment in a minute. So, if our y difference is 0, then we need to be looking at whether to move up or down on the x coordinate. So light x against initial x. If our light x is greater than our initial x, the light must be on our right hand side, in which case we need to head east. If we're heading east, that means our Thor x coordinate needs increasing by 1. In the other component, if our light x is less than our Thor position, then we need to head left. And if we're heading left, we're going to be heading west, and our x position is going to go down by 1. Perfect. All going well so far. Now, if within the loop Thor is in line with his light, he will head straight towards it, whether it's north, south, east or west. But what if it's not straight in a line? What if x isn't 0 or y isn't 0? We need to do some kind of diagonal movement that will take care of that. Well, that's where we're going into a whole new set of ifs. So, if x diff is not 0, else. If y diff is not 0, we go into this else. What we're going to do? Well, we're going to do a brand new if. Of course, we're putting ifs all over the place now. Now, we need to work out which direction we need to go diagonally, and this is going to be very similar to how we did it last episode, but again, we're bringing it all together and we're tracking our movement this time to work out each game loop if we need to change direction, because he will change direction. Because we are changing this initial ty and changing this initial tx, when it does this calculation at the beginning of the loop to check what the difference is going to change all the time. So let's check that difference. Let's say the x difference. If the x difference is greater than 0 and the y difference is also greater than 0, then what do we do? Well, this is similar to what we did last time. If the light is higher on the x side and if it's higher on the y side, then we need to head over to the southwest. That's what we need to do. Direction equals southwest. Put it in some speech marks because it's some text. There we go. But of course, we need to tell our little loop that we've moved. We need to change this initial Thor direction. So if we go under here, we need to do what southwest is. Well, southwest is adding 1 to both the x and the y. So if we say Thor initial x plus 1, there we go, and Thor initial y plus 1. I'm just stealing the code from up here because we've already typed it before. And then that's going to be the end of the if. There we go. End of if. So now we need to look at the other differences because there's 4 different possible combinations. So I guess let's put them all out on the screen. So let's do 1 there, 1 there, and 1 there. Alright, tidy up the indentation. Always good indentation. Indentation in coding allows you to work out exactly what you're doing. I would get lost in if statements if I didn't use indentation. So I guess, what are the options? Well, the x difference could be less than 0. It could be negative. The y difference could be negative. Or both x and y could be negative. And there we are. Those... Oh, didn't mean to do that. Let's just get rid of that. Those are the different possible combinations for heading diagonally. We need to sort out these bits, so let's do that now. So, if x is less than 0, so if the difference is less than 0, it means we're heading over to the west, I think. Oh, hang on a second. Did I get this bit wrong? Hang on, let me just double check this top one. Oh, no, we need to be heading southeast on this one. That's a typo. That's a typo. Right, folks, I hope you noticed that. So, yes, if we're heading in the positive x direction and the positive y direction, we need to be going to this bottom right-hand corner, which is southeast. Now, I noticed that because this one over here, if the x-coordinate is negative and the y-coordinate is positive, then we're going to be heading southwest. Brilliant. Now, the only thing here is we need now to remark his position. So, the x-coordinate is going to decrease by 1. Decrease by 1, take 1 off. Okay, brilliant. And now down here, if the difference is positive in the x and negative in the y, that means that he wants to go up to the top right hand corner. That's the northeast. Northeast. Brilliant. And if we're going up that way, then x is increasing but y is decreasing. So we put a -1 there. Brilliant. And if x is negative and y is negative, then the light source is to the northwest up in this top corner behind him. So let's put northwest and let's make both of these negative because he's moving in the negative direction along both of these axes. Then all we do is at the end of this we need to make sure we've got all our ends in. So we've got an if statement here without an end if. And we've got an if statement here without an end if. Should have really put them in as I was going along. Good practice, I think. And at the end of that end if, we're now going to output that direction. Now we've already got that from last episode, sat here. Console, right line, direction. Right, so, and then it will calculate the difference at the beginning of each loop and carry on again. Let's see if this works. To be honest, I haven't tested this. This was just something I thought of as I was driving home from work. So let's check our straight line one. Fingers crossed, folks. No, nothing happened. Why? What happened? Oh, we got an error message. Xdiff is not declared and it may be inaccessible. Ooh, right, okay. We need to declare our function. Our variable. So let's go up to where xdiff is here. There it is. And just before xdiff, let's make sure we declare it. So we're going to dim, which means a kind of declaration, xdiff. And of course, we need to do the same for xy. Sorry, y diff. Okay, let's try again. Let's see if I've got any other errors in this. Okay. Oh, wow, look, he's heading in the right direction. Brilliant. Energy is going down. 88 energy, 85. It's down here in the bottom corner. You can see Thor's position moving. He gets the light source. Ta-da! Brilliant. So straight line works. Let's try up. So in the up scenario, his y coordinate is wrong, but his x coordinate is 0, so he goes north. Well, so far the logic is good. Let's try the easy angle. So Thor is going diagonal to get in line with the light. Once he gets in line with the light, he doesn't. The x coordinate is now the y coordinate is now 0, so he's heading straight into it. He's heading east. Brilliant. Let's just have a look at that last bit again. So he was heading diagonal to the southwest. So that means as he was moving, this piece of code was active. So the difference in the x coordinate was negative and the difference in the y coordinate was positive. So if we look at the x coordinates and the legend on the top corner here and the y coordinates, he was heading negative x, which was to the left, and positive y, which was down. So he's going diagonal. Then when he became in line with the light, so y was equal to 0, he then... Where's y equal to 0? There's the y equal to 0 condition. He then decided that his position was in a negative quantity to the light. The light was negatively behind him. So because the light was behind him, this part of the second if condition was true. And he headed west. Right, let's play the next test case and see what happens. I haven't even looked at this one. So an optimum angle. So now Thor is heading diagonally towards the light first, and then once his y coordinate is 0, he will head straight towards it. Now it looks like we've only just got enough energy to get there, so we have to do it in an efficient way. Have we done it in an efficient way? Yes, we have. We got there just in time. Right, and that's all the test cases for this scenario. So all we did here was we just checked the difference between Thor and the light in each loop. And once we checked the difference between Thor and the light, we decided which way we was going to go based on that difference. And of course, we made a note of our change. Now what we could have done is we could have gone from an initial check and saved a secondary variable to Thor new position and made the new position equal to the old position plus 1 or minus 1, but that seemed like too much messing around to me, so I just kept the original variable, and there it is. Well, Power of Thor episode 1 is complete. We have successfully played all the test cases, and Thor managed to retrieve the light and save the Earth. Well, we're coming towards the end of the episode, and I would like to do a game giveaway. The game I've got to give away is 1001 Spikes, and it's through the Steam network. All you have to do to be within a chance of winning this game is leave a comment in the comment section on YouTube below. At the end of your comment, put 3 exclamation marks. Those exclamation marks let me know that you want to be part of the competition, and sometime after 7 days from this video being released, I will pick one random winner from up to the first 100 entrants. That person will then be contacted by me through YouTube, and I'll send you a link to where you can retrieve your prize. So leave your comments down below, any comment you like, put your 3 exclamation marks at the end, and good luck. Well, leave all your thoughts, ideas and questions down in the comments as always. Thank you very much for watching, and I'll see you sometime soon for another Coding Game episode. Goodbye.